In the ever-evolving landscape of space exploration and research, significant developments continue to shape the future of this critical field. On February 25, 2025, two standout stories emerged highlighting both astronomical wonders and the challenges facing NASA's commitment to diversity in its workforce. The astronomy picture of the day featured an awe-inspiring image of the M41 star cluster known as the Little Beehive. Captured by photographer Xinran, the image showcases a stunning array of bright blue stars indicative of their youth and massive size. As Dr. Robert Nemiroff and Dr. Jerry Bonnell explained, these luminous stars are typically born in clusters like M41, where they shine brightly due to their immense mass. The cluster also contains less bright non-blue stars, including our own Sun, which are often harder to detect. The vibrant orange-red giant stars and the diffuse hydrogen gas filaments enhance the visual appeal of the image, providing a glimpse into the dynamic processes of star formation. However, this beauty is transient. In about 100 million years, the blue stars will likely explode in supernovae, ultimately dispersing the cluster. This daily feature not only captivates the audience but also serves to educate the public about the complexities and transient nature of our universe. In a more terrestrial development, Western Kentucky University WKU announced a significant achievement in its research endeavors. The institution's Department of Physics and Astronomy was awarded a NASA Kentucky-established program to stimulate competitive research EPSCoR grant totaling $900,000. This funding will support a project centered on solar activity and space weather, specifically investigating solar flares using advanced pulsed laser deposition techniques. Dr. Gordon Emsley, a key member of the research team, emphasized the importance of this work, stating, "Observing at these wavelengths is important because the light is produced by high-temperature million-degree material in the sun during solar flares. The research aims to enhance the understanding of solar phenomena that can have significant effects on Earth, including potential disruptions to satellite communications and power grids." However, this scientific progress comes against a backdrop of political controversy. A recent executive order from President Trump has led to the dismantling of diversity, equity, and inclusion (DEI) initiatives at NASA. This has raised alarm among advocates for diversity within the space agency, who fear that the hard-won progress in achieving a more inclusive workforce may be reversed. Edward Joseph Dwight Jr., the first black astronaut trainee, expressed his dismay, labeling the current political climate as bordering on insanity. There are concerns that these changes could hinder the agency's ability to recruit and retain a diverse pool of talent necessary for future space missions. As NASA grapples with these challenges, the agency's commitment to fostering a diverse workforce remains uncertain. In a related push, Florida Governor Ron DeSantis proposed relocating NASA's headquarters from Washington, D.C. to Florida's Space Coast, arguing that such a move would save taxpayer money and enhance collaboration with private aerospace companies. This suggestion comes at a time of heightened scrutiny over NASA's budget and operational efficiency. The governor's remarks reflect a growing sentiment among some lawmakers that the space agency could benefit from being closer to its operational hubs, particularly in light of Florida's rich aerospace industry. As the conversation around NASA's future unfolds, it simultaneously highlights the need for a balanced approach that respects the importance of diversity while embracing operational efficiency. The coming months may prove pivotal as NASA navigates these complex issues, potentially impacting the agency's mission and its role in global space exploration. As we look ahead, the outcomes of these initiatives and political shifts will undoubtedly shape the next chapter in humanity's quest to explore the cosmos. NASA continues to push the boundaries of scientific research aboard the International Space Station (ISS), with recent findings from 2024 showcasing an impressive array of experiments that could shape the future of space exploration and technology on Earth. Over the past year, NASA and its international partners conducted 361 investigations, contributing to a total of more than 400 research publications since the launch of the ISS over 25 years ago. The results of these investigations not only enhance our understanding of fundamental scientific processes but also pave the way for advancements in various fields from construction to healthcare. One significant study, the microgravity investigation of cement solidification (MICS), explored the hydration and hardening of cement in a microgravity environment. Researchers employed artificial intelligence to create detailed 3D models from 2D images of cement samples, allowing them to predict internal structures that are critical for the integrity of concrete-like materials. The findings could lead to groundbreaking innovations in civil engineering and materials manufacturing, which are essential for long-term space missions where reliable construction materials are crucial. In a separate experiment, the Japan Aerospace Exploration Agency (JAXA) investigated the creation of colloidal clusters. By manipulating oppositely charged particles to form pyramid-shaped structures, researchers discovered that these clusters can scatter light in ways that are beneficial for advanced optical technologies. Such insights could revolutionize the design of sensors and computing components, potentially leading to breakthroughs in high-speed data transmission and even cloaking devices. Another noteworthy investigation focused on the dynamics of bubble formation in microgravity. The optical imaging of bubble dynamics on nanostructured surfaces experiment revealed that bubbles grow significantly larger and faster in space compared to Earth, with implications for improving thermal management technologies. Understanding how these bubbles behave could enhance the design of cooling systems and sensors used in various applications. The effects of microgravity on human biology were also under the microscope, with the European Space Agency's cytoskeleton study examining how space conditions impact cellular processes. Researchers identified 24 pathways affected by microgravity in human bone cells, revealing potential links to aging and inflammation. These insights are crucial for developing countermeasures to maintain astronaut health during extended missions. As astronauts navigate the challenges of living in space, research has also targeted cognitive functions. The Canadian Space Agency's wayfinding investigation assessed how microgravity affects spatial awareness and orientation skills. Findings indicated reduced activity in brain regions responsible for processing spatial information, which could inform strategies to enhance astronauts' performance in complex tasks during missions. Monitoring the environment of low Earth orbit is equally vital, as demonstrated by the Mini-USO project, a collaborative effort among Roscosmos ESA and the Italian Space Agency. This multipurpose telescope has contributed to the development of a machine learning algorithm capable of detecting space debris and meteors with greater precision. Such advancements are essential for ensuring the safety of both crewed and uncrewed space missions. While significant strides are being made in scientific research, lighter moments are also part of life aboard the ISS. NASA astronaut Don Pettit recently entertained viewers with a whimsical challenge to float himself into a pair of pants in microgravity, showcasing the playful side of scientific inquiry. This light-hearted demonstration not only provided entertainment but also served as a practical illustration of the unique challenges astronauts face in their everyday lives. As these remarkable studies continue to unfold, the knowledge gained from the ISS will undoubtedly inform future space exploration initiatives, including NASA's Artemis program aimed at returning humans to the Moon and eventually Mars. The ongoing research aboard the ISS not only enhances our understanding of fundamental science but also equips humanity with the tools necessary for sustainable exploration and habitation beyond Earth. As we look to the stars, the continued collaboration among international space agencies will be pivotal in unlocking the mysteries of the cosmos while ensuring the safety and health of those who venture into its depths. In a remarkable testament to the enduring spirit of scientific inquiry and innovation, NASA has unveiled a series of groundbreaking research findings from the International Space Station (ISS) that were published in 2024. As NASA and its international partners celebrate over 25 years of collaborative research in microgravity, these results not only advance our understanding of fundamental scientific principles but also hold significant implications for technology development on Earth and future space missions. One of the standout experiments is NASA's microgravity investigation of cement solidification (MICS), which delves into the hydration reaction and hardening processes of cement in space. Using artificial intelligence, researchers were able to create intricate 3D models from 2D images of cement samples, revealing critical insights into pore distribution and crystal growth that could enhance the integrity of concrete-like materials. These advancements could revolutionize civil engineering and construction techniques, especially in the context of building habitats on other planets, stated a member of the MICS research team. The Japanese Aerospace Exploration Agency JAXA contributed through its colloidal clusters investigation, where researchers harnessed the attractive forces between charged particles to form pyramid-shaped clusters. These clusters, essential for creating advanced materials, have the potential to enhance optical and laser communications systems on Earth. The ability to manipulate light effectively could lead to breakthroughs in high-speed computing and even cloaking technologies, showcasing the far-reaching impacts of space research on terrestrial applications. In another innovative study, NASA examined bubble dynamics in microgravity, revealing that bubbles formed during boiling are significantly larger and grow at an accelerated rate compared to those on Earth. Utilizing nanostructured surfaces, researchers discovered how surface textures influence heat transfer and bubble formation. These findings could inform the design of more efficient thermal cooling systems, crucial for both spacecraft and various industrial applications. The European Space Agency's ESA cytoskeleton investigation took a deeper look into the cellular responses to microgravity, identifying pathways affected by the unique environment of space. By studying human bone cell cultures, researchers found a reduction in cellular expansion and increased activity in pathways associated with inflammation and stress. These insights could be pivotal in developing countermeasures to maintain astronaut health during long-duration missions. Further research from the Canadian Space Agency CSA explored how microgravity affects spatial awareness in astronauts. The study revealed reduced activity in brain regions responsible for spatial processing, suggesting that the absence of gravity cues significantly hinders their ability to perform complex tasks. Understanding these cognitive challenges is essential for designing better training and operational protocols for astronauts on future missions. Moreover, the collaborative mini-USO project supported by Roscosmos ESA and the Italian Space Agency has been instrumental in monitoring low Earth orbit. The multipurpose telescope has proven effective in detecting space debris and meteors, leveraging machine learning algorithms that enhance the safety of current and future space activities. As these diverse research initiatives highlight, the ISS continues to serve as a vital laboratory for scientific exploration, enabling discoveries that transcend the confines of Earth. With over 4,400 publications resulting from more than 4,000 investigations, the ISS remains a beacon of global cooperation and groundbreaking research. Looking ahead, the implications of these studies extend far beyond the realm of space exploration. As NASA prepares for its Artemis missions and future endeavors to Mars and beyond, the knowledge gained from these experiments will be crucial in addressing the challenges of colonizing other planets and ensuring the health and safety of astronauts. The intersection of space research and technological advancement promises to unlock new potentials both in the cosmos and on our home planet, paving the way for a future where exploration knows no bounds. In a remarkable showcase of international collaboration and scientific advancement, NASA has announced a sweeping array of research findings from the International Space Station ISS that promise to propel technology and understanding in various fields. The results published in 2024 underscore the station's role as a vital laboratory for innovation that not only benefits space exploration but also has profound implications for life on Earth. For over 25 years, NASA and its global partners have conducted thousands of experiments aboard the ISS, yielding more than 4,400 publications with 361 research papers released in 2024 alone. These investigations span a diverse range of applications from materials science to health research, showcasing the ISS as a unique environment where the effects of microgravity can be studied in depth. One standout research initiative: the microgravity investigation of cement solidification (MICS). has leveraged artificial intelligence to create three-dimensional models from two-dimensional images of cement samples solidified in microgravity. This innovative approach has provided insights into the hydration and hardening processes of cement, potentially transforming civil engineering practices not only on Earth but also in future space missions. As NASA researcher Alexander Gerst noted, understanding these processes in microgravity could lead to advancements in construction materials that perform better under extreme conditions. Another significant study conducted by the Japan Aerospace Exploration Agency JAXA focused on colloidal clusters formed from oppositely charged particles. These pyramid-shaped formations are essential in creating a diamond lattice structure which has advanced light manipulation capabilities. Researchers found that these clusters, when immobilized on the space station, can scatter light in ways that enhance optical and laser communications systems. This research could pave the way for new technologies in high-speed computing and sensing applications. NASA's exploration into bubble dynamics on nanostructured surfaces revealed that microgravity vastly alters bubble behavior. The optical imaging of bubble dynamics study demonstrated that bubbles grow larger and faster in space, which has implications for designing more efficient cooling systems and sensors that utilize bubble dynamics. The fundamental insights we gain from this research could lead to breakthroughs in thermal management solutions, explained lead researcher Tingfei Luo. In the realm of biological research, the ESA's cytoskeleton investigation has uncovered how microgravity affects human cell processes, particularly in bone cells. This research identified pathways linked to cellular stress and inflammation, providing critical data that may inform countermeasures against the adverse health effects of space travel on astronauts. Furthermore, research conducted by the Canadian Space Agency investigated how prolonged exposure to microgravity impacts astronauts' spatial awareness. Findings indicated reduced activity in brain regions responsible for spatial processing, suggesting that astronauts may face challenges in orientation and balance during long-duration missions. Such insights are invaluable for developing strategies to improve astronaut training and performance in space. On the monitoring front, the Mini-EUSO Telescope project, a collaboration between Roscosmos ESA and the Italian Space Agency, has yielded promising data on detecting space debris and meteors. By employing advanced machine learning algorithms, researchers aim to enhance safety for orbital missions, which is increasingly crucial as the space environment becomes more congested. The significance of these findings extends beyond the realm of space exploration. They have the potential to influence various earthbound technologies, from construction materials to healthcare solutions, and underscore the importance of sustained investment in space research. The results from the ISS demonstrate that the challenges of space exploration can lead to innovations with tangible benefits on Earth. As we look to the future, the ongoing partnership between nations and space agencies will only deepen, fostering a new era of scientific exploration. With the promise of new technologies and insights gleaned from the microgravity environment, the legacy of the ISS will undoubtedly continue to inspire future generations of scientists and innovators. The results from 2024 are just a glimpse of the vast potential that remains to be unlocked in the final frontier. A recent study has unveiled new insights into the iconic red hue of Mars, shedding light on the planet's potentially habitable past. This research, which was partially funded by NASA, suggests that the red color may be attributed to a water-rich iron mineral known as ferrihydrite, indicating that Mars could have once sustained liquid water under more favorable climatic conditions than previously understood. Mars is widely recognized for its rusty red appearance, a color traditionally associated with iron oxides. However, the prevailing theory had linked this hue to the mineral hematite, which is formed in dry conditions. The groundbreaking findings published on February 25 in the journal Nature Communications propose a shift in this narrative. Lead author Adam Valentinez, a postdoctoral fellow at Brown University, emphasized the significance of their discovery, stating ferrihydrite is everywhere in the dust and also probably in the rock formations. This assertion builds on previous studies that hinted at ferrihydrite's role but lacked the comprehensive analysis conducted in this research. The implications of this study are profound. If ferrihydrite, which forms in the presence of cool water, is indeed responsible for Mars' red coloration, it suggests that the planet experienced a wetter environment much earlier than previously thought. The study integrates data from several Mars missions, including NASA's Mars Reconnaissance Orbiter and ESA's Mars Express and Trace Gas Orbiter. By combining orbital observations with ground-level measurements from rovers like Curiosity, Sojourner and Opportunity, the researchers were able to analyze Martian dust and its mineral composition more effectively. Valentines pointed out that understanding the conditions during the formation of ferrihydrite is crucial for addressing the habitability question of Mars. To understand whether there was ever life, you need to know the conditions that were present during the time this mineral formed, he explained. The research suggests that for ferrihydrite to form, there must have been interactions between iron, water, and oxygen. Conditions that starkly contrast with today's cold and dry Martian environment. The study's findings also resonate with the broader goals of space exploration and the search for life beyond Earth. Geronimo Villanueva, Associate Director for Strategic Science at NASA's Goddard Space Flight Center, remarked on the collaborative nature of this research. These new findings point to a potentially habitable past for Mars and highlight the value of coordinated research between NASA and its international partners, he said. Researchers are looking forward to the return of samples collected by NASA's Perseverance rover, which could provide definitive evidence regarding the presence of ferrihydrite on Mars. Jack Mustard, a senior author of the study, described the study as a door-opening opportunity, emphasizing the potential for analyzing Martian materials in Earth laboratories. As NASA and its partners continue to explore the red planet, this latest research not only enhances our understanding of Mars but also raises intriguing questions about its climatic history and the potential for past life. The findings mark a significant step in the ongoing quest to unravel the mysteries of our neighboring planet and could lead to further revelations as new missions are launched and data is analyzed in the years to come. With future explorations on the horizon, the narrative of Mars' past continues to evolve, potentially revealing a world that was once vibrant and teeming with life. NASA is making significant strides in its ambitious lunar exploration agenda, with recent developments centered around the Gateway Lunar Space Station and a series of upcoming lunar landings. As part of the Artemis program, NASA is not only preparing for a return to the Moon but is also laying the groundwork for human exploration of Mars. The assembly of the Gateway's power and propulsion element is currently underway at Maxar Space Systems in Palo Alto, California. This module will be pivotal for powering the Lunar Space Station on its journey to and around the Moon. The power and propulsion element is designed to make Gateway the most powerful solar electric spacecraft ever launched, enabling unique scientific research and exploration in lunar orbit. Technicians are currently installing critical hardware, including both electric and chemical propulsion control modules essential for the operations of this state-of-the-art facility. Gateway will serve as a key component in NASA's Artemis 4 mission, which aims to establish a human presence on the Moon. Astronauts will inhabit the Gateway, facilitating expeditions to the Moon's South Pole and beyond. This multinational collaboration emphasizes not just lunar exploration but also prepares astronauts for future missions to Mars. As NASA's Gateway program manager articulated, the Gateway will enhance our capability to conduct scientific research and prepare for human missions to Mars, marking a significant leap in our exploration efforts. The upcoming Artemis missions are not the only focus of NASA's lunar endeavors. Intuitive Machines is set to launch its second lunar lander, Athena, which is poised to explore the Moon's South Pole region. This mission is particularly exciting as it represents a blend of NASA's goals and commercial partnerships. The Athena lander will carry a suite of scientific instruments designed to investigate the Moon's resources, including a water hunting drill named Prime 1. This dual instrument will drill into the lunar surface and analyze the soil, seeking potential resources for future human habitation. NASA's Artemis program also aims to utilize commercial partnerships to expedite the return to the Moon. For instance, Firefly Aerospace's Blue Ghost spacecraft is slated for a soft landing on the lunar surface carrying 10 science investigations for NASA. This mission, part of NASA's Commercial Lunar Payload Services (CLPS) program, reflects the agency's strategy to leverage private sector capabilities to enhance lunar exploration. In parallel to these lunar missions, NASA's Europa Clipper is leveraging a gravity assist from Mars to reach its destination in the Jupiter system. Scheduled for a flyby of Mars on March 1, 2025, the spacecraft will use this maneuver not only to adjust its trajectory but also to test its scientific instruments in close proximity to the red planet. This gravity assist technique, which has been a hallmark of NASA missions since the Voyager days, allows for more efficient travel across the solar system without the need for excessive fuel. As NASA continues to forge ahead with these ambitious plans, the implications for scientific discovery and human exploration are profound. The Gateway Lunar Space Station and the commercial lunar missions are set to provide invaluable data about the Moon and pave the way for sustainable human presence there. The progress being made now will not only deepen our understanding of lunar resources but also lay the foundation for the first human missions to Mars, anticipated as early as 2027. In conclusion, NASA's current initiatives reflect a multifaceted approach to space exploration, blending international collaboration, commercial partnerships, and innovative technologies. As the agency prepares for its next giant leap into the cosmos, the coming years promise to be thrilling for space enthusiasts and scientists alike. The successful execution of these missions will undoubtedly shape humanity's journey into deeper space, transforming the Moon into a stepping stone for future planetary exploration.